Welcome to the Hypnos Sleep Channel. Tonight, Hypnos, the ancient Greek god of sleep, will guide us gently through one of humanity's most persistent dreams, the dream of traveling faster than light. Not through the lens of equations and theories, but through the imagination of storytellers who dared to ask, what if we could? In 1966, a television show called Star Trek introduced the world to warp drive. It was not the first story to imagine faster-than-light travel, but it was the first to make it feel like engineering, like something real, something with rules, something humanity might one day build. Tonight, we trace those rules. We follow the warp scale from 1 to 10. We visit the starships that carried us across the galaxy, and we ask the question that has lingered for 60 years. Could warp speed ever be more than fantasy? Find a comfortable position. Let the weight of the day loosen. The journey is long, but there is no hurry here. Warp Factor 1. Engage. Before there was a Starship Enterprise, before there were warp cores and dilithium crystals and chief engineers shouting about the laws of physics, there was a man in a small town in Montana. His name was Zephram Cochrane. In the Star Trek universe, Cochrane built humanity's first warp-capable vessel, the Phoenix, in the aftermath of World War III. On April 5, 2063, he launched from Bozeman, Montana, using a converted intercontinental ballistic missile. When the Phoenix broke the light barrier, the subspace signature was detected by a passing Vulcan survey ship. First contact. The moment humanity joined the galactic community. The warp drive Cochrane built worked by generating a subspace field around the ship. This field warped the fabric of space-time, contracting space in front of the vessel and expanding it behind. The ship itself never exceeded the speed of light within its local reference frame. It was space-time that moved. This is the same principle Miguel Alcubierre would formalize in his 1994 paper, 3 decades after Star Trek first imagined it. Cochrane's original warp scale was simple. Warp factor 1 was the speed of light, and the velocity increased as the cube of the warp factor. Warp 2 was 8 times light speed. Warp 3 was 27 times. Warp 4 was 64 times. Warp 5, 125 times the speed of light. This cubic scale was the law of the original series era. Captain Kirk's Enterprise, a Constitution-class heavy cruiser, could sustain Warp 6, 216 times light speed. In an emergency, she could push to Warp 8, 512 times light speed. At those speeds, the journey from Earth to Alpha Centauri, 4.37 light-years away, would take approximately 8 days at Warp 6. But the stars are far apart. The Federation spans 8,000 light-years. Even at Warp 8, crossing from one end to the other would take more than 15 years. The galaxy is vast, and the original series warp scale, for all its simplicity, could not keep up with the storytelling demands of a universe that kept getting bigger. When Star Trek: The Next Generation premiered in 1987, the universe had expanded. The Enterprise D was a Galaxy-class starship, larger, faster, more powerful than anything Kirk had commanded. The old cubic warp scale was no longer sufficient. The writers needed ships that could cross the galaxy in weeks, not years. Gene Roddenberry and the technical consultants devised a new warp scale. Warp Factor 1 remained the speed of light, but from Warp 9 onward, the scale became asymptotic, approaching infinity as it neared Warp 10. Warp 10 was not a speed. Warp 10 was everywhere at once. It was infinite velocity. It was, in the words of the Star Trek: The Next Generation Technical Manual, the theoretical maximum. The new scale was defined by the equation: velocity equals the warp factor raised to the power of 10^3, multiplied by the speed of light. For warp factors below 9, This produced speeds roughly in line with the old cubic scale, but above warp 9, the numbers exploded. Warp 9.0, 1,516 times light speed. Warp 9.6, 1,909 times. Warp 9.9, 3,053 times. Warp 9.975, approximately 5,000 times. Warp 9.99, 7,912 times. Every decimal point mattered. The difference between Warp 9.9 and Warp 9.99 was the difference between crossing the Federation in a year and crossing it in a month. This asymptotic scale created drama. The Enterprise D had a normal cruising speed of Warp 6, 392 times light speed. Its maximum sustainable speed was Warp 9.2, 1,649 times light speed. In an emergency, it could push to Warp 9.6 for 12 hours. Beyond that, the ship began to tear itself apart. The scale also created limits. If Warp 10 was infinite, it was unreachable except through extraordinary means. This was explored in the Voyager episode Threshold, where Lieutenant Tom Paris breaks the Warp 10 barrier, and the results are not what anyone expected. He experiences being everywhere at once, every point in the universe simultaneously, and the experience transforms him into something no longer entirely human. The episode was controversial among fans, but it established a fundamental principle. Warp 10 is not a destination. It is a boundary condition. It is the edge of what physical law permits. Every starship class had its own warp capability, its own relationship with the speed scale. These numbers were not merely technical trivia. They defined the character of each vessel, the reach of each crew, the scope of the stories that could be told. The NX-01 Enterprise, Earth's first Warp 5 starship, launched in 2151 under Captain Jonathan Archer. Warp 5, 125 times light speed, was the threshold that made interstellar exploration practical. At that speed, the journey to the nearby Klingon Empire, approximately 100 light-years from Earth, took less than a year. The NX class could sprint to Warp 5.2, approximately 140 times light speed, but sustained speed was lower. This was the ship that built the alliances that would become the Federation. Kirk's Constitution-class Enterprise operated on the old cubic scale. Warp 6 cruising, Warp 8 emergency. At Warp 6, the 5-year mission to explore strange new worlds could reach any star within approximately 100 light-years of Earth and return. This was the scope of the original series, a frontier measured in hundreds of light-years, not thousands. The galaxy was still huge, but it felt approachable. The Excelsior class, introduced in Star Trek III, the search for Spock, was designed to be the great experiment. Transwarp drive, a propulsion system that would render the old warp scale obsolete. Transwarp failed. The Excelsior was refitted with conventional warp drive and became the workhorse of the fleet for nearly a century. Its top speed was Warp 9, 729 times light speed under the old cubic scale, or approximately 1,000 times light speed under the new asymptotic scale, depending on which reference you consult. The Ambassador class, Enterprise C, bridged the gap between the Excelsior era and the Galaxy class era. Warp 9.2 cruising, Warp 9.6 emergency. This was the ship that sacrificed itself at Narendra III, defending a Klingon outpost from Romulan attack. An act of honor that would reshape Federation-Klingon relations for a generation. The Galaxy-class Enterprise D was, in its era, the pinnacle of Federation engineering. Warp 9.6 for 12 hours. At that speed, the ship could travel approximately 2,000 light-years in a year. the Enterprise D could reach the edge of the Federation and return within a standard tour of duty. But even a Galaxy-class ship could not explore the entire galaxy. The Milky Way is 100,000 light-years across. At maximum warp, crossing from one side to the other would take nearly 50 years. The Intrepid class, Voyager, changed the equation. Its variable geometry warp nacelles, the pivoting pylons that raised before engaging warp drive, were not merely aesthetic. They were a response to a Federation study that showed standard warp configurations were damaging the fabric of subspace. The Intrepid class could maintain warp 9.975, more than 3,000 times light speed, for sustained periods without causing subspace degradation. This was the ship that was hurled 70,000 light-years across the galaxy to the Delta Quadrant. At maximum sustainable warp, the journey home would have taken 75 years. Voyager's entire premise was the tension between that number and every shortcut, every wormhole, every alien technology that might reduce it. The Sovereign-class Enterprise E, introduced in Star Trek, First Contact, pushed the envelope further. Warp 9.7 cruising, Warp 9.99 emergency. At those speeds, the Federation's reach extended to thousands of light-years within a standard mission duration. This was the ship that faced the Borg, and won. The Prometheus class, an experimental vessel introduced in Voyager, was capable of warp 9.9, more than 3,000 times light speed, and could split into 3 separate warp-capable sections. Multi-vector assault mode. 3 ships attacking from 3 directions, each traveling faster than anything the Federation had fielded a generation earlier. The Prometheus represented the apex of Starfleet's tactical warp technology. And then there were the ships beyond Starfleet. The Borg cubes, traveling at transwarp speeds through conduits, artificial corridors of subspace that connected distant regions of the galaxy. Transwarp rendered the standard warp scale meaningless. A Borg cube could travel from the Delta Quadrant to Earth in minutes, not decades. The Voth, an ancient saurian species from the Delta Quadrant, possessed transwarp drives that made even Borg technology look primitive, crossing thousands of light-years in seconds. At the far end of the scale, Species 8472 from fluidic space used quantum singularities to travel between dimensions, a form of propulsion that was not warp drive at all but something fundamentally different, the manipulation of the boundary between realities. The warp scale, for all its complexity, was always a local convention. It described what the Federation could do, but the galaxy was full of civilizations that had outgrown it. The in-universe physics of warp drive is explored across hundreds of episodes and films, and while it is fictional physics, it is internally consistent, a remarkable achievement for a television franchise spanning 6 decades. The core component of any warp propulsion system is the warp core. This is a matter-antimatter reactor. Deuterium, a hydrogen isotope, is injected into the reaction chamber. Anti-deuterium, antimatter, stored in magnetic containment bottles, is injected simultaneously. The two annihilate on contact, releasing enormous energy. This energy is regulated by dilithium crystals, a fictional mineral that is porous to antimatter when exposed to high-frequency electromagnetic fields. The dilithium crystal acts as a throttle, controlling the rate of annihilation and therefore the power output. The energy from the warp core is channeled to the warp nacelles, the elongated pods mounted on pylons away from the ship's hull. Inside each nacelle are a series of warp coils, typically made of verterium cortinide. When energized by plasma from the warp core, these coils generate a subspace displacement field, the warp bubble. The bubble is asymmetric. It compresses space in front of the ship and expands it behind. The ship rides inside a region of flat space-time, never locally exceeding c, while the bubble itself moves at effective superluminal speeds. This is precisely the concept Miguel Alcubierre would formalize in 1994, a warp bubble that contracts space-time ahead and expands it behind, with the ship riding a wave of warped geometry. Star Trek got there first, in 1966, as fiction. The mathematics caught up 28 years later. The subspace field serves a second function beyond propulsion. It reduces the effective mass of the ship, a phenomenon the technical manuals call subspace driver coil mass reduction. In Newtonian terms, the ship becomes lighter within the field, requiring less energy to accelerate. This helps address the energy problem. Even with matter-antimatter annihilation, the power required to accelerate a 4 million-ton starship to relativistic speeds would be prohibitive without mass reduction. Warp drive in the Star Trek universe has limitations and dangers beyond mere speed. Sustained high warp travel above warp 5 was discovered in the TNG era to cause cumulative damage to the fabric of subspace. A region of space repeatedly traversed at high warp would develop subspace rifts, tears in the underlying structure that could disrupt warp travel and, in extreme cases, threaten inhabited worlds. This was the so-called Warp 5 speed limit imposed by the Federation Council, later relaxed as new nacelle designs, such as Voyager's variable geometry pylons, mitigated the damage. Warp drive also creates a detectable signature. A ship at warp emits subspace radiation, warp signature that can be detected at considerable range. Stealth at warp is nearly impossible. The approach of a high warp vessel is visible for light hours in every direction. This is why cloaking devices were so coveted, not because they hid a stationary ship, but because they could hide a ship traveling at warp, something that no other technology could do. The Romulan and Klingon cloaks that so bedeviled Starfleet were, at their core, a solution to the warp signature problem. Let us now make a quiet journey through the warp scale itself, from factor 1 to the edge of factor 10, and see what each threshold means, not as a number, but as an experience. Before we leave the solar system behind, it helps to anchor the scale in familiar distances. Light from the Moon takes about 1.3 seconds to reach Earth. Light from Mars, depending on where both planets are in their orbits, takes roughly 3 to 22 minutes. Jupiter is usually tens of light minutes away. Saturn is a little over an hour of light time away. Neptune is about 4 light hours from us. At warp 1, those are still the travel times. Seconds to the Moon, minutes to Mars, hours to the outer planets. But at warp 5 on the next generation scale, those same distances nearly vanish. Earth to Mars becomes a matter of about 1 to 6 seconds. Earth to Jupiter becomes roughly 10 to 15 seconds. Earth to Saturn becomes about 20 to 25 seconds. Earth to Neptune becomes a little over 1 minute. At warp 9, even Neptune is only about 10 seconds away. This is why Star Trek rarely treats planets inside one solar system as truly distant. The real ocean is not between Earth and Mars. It is between stars. The nearest star system, Alpha Centauri, is 4.37 light-years away. Sirius is 8.6 light-years away. Epsilon Eridani is about 10.5 light-years away. Tau Ceti is nearly 12 light-years away. These names are close neighbors by cosmic standards, but at chemical rocket speeds, they are effectively unreachable. Warp drive changes the emotional meaning of the map. It turns light years from walls into weather. Warp factor 1. The speed of light. 300,000 kilometers per second. At this speed, it would take a little over 4 years to reach Alpha Centauri. The nearest star is close enough to feel, but not close enough to touch, not in any human lifetime. Warp 1 is the gate. It is the moment the Phoenix broke through and everything changed. Warp factor 2. 8 times light speed on the original cubic scale, and just over 10 times light speed on the later next generation scale. Alpha Centauri in roughly 5 to 6.5 months, depending on which scale the story is using. The nearest dozen stars become reachable within a single mission. This was the speed of the earliest Earth warp vessels, the ships that charted the first trade routes to Vulcan and Andoria. Warp factor 3. 39 times light speed on the TNG scale. Alpha Centauri in 40 days. The distance from Earth to Vulcan, approximately 16 light-years, in 5 months. This was the dawn of true interstellar civilization. Warp factor 4, 102 times light speed. Alpha Centauri in 15 days. At this speed, a ship could visit a dozen star systems within a year. The NX-01 Enterprise, Earth's first deep space explorer, operated in this regime. Warp factor 5, 214 times light speed. Alpha Centauri in 1 week. Earth to Vulcan in less than a month. This was the speed threshold that transformed the Federation from a collection of neighboring worlds into a true interstellar power. Warp factor 6, 392 times light speed. Alpha Centauri in 4 days. The standard cruising speed of the Galaxy-class Enterprise D. At Warp 6, the ship could cover approximately 400 light-years in a standard year. This was the speed of routine operations, of patrols and scientific surveys and diplomatic missions. Warp factor 7, 656 times light speed. Alpha Centauri in 2.5 days. At this speed, the ship begins to feel the strain. Warp 7 is the boundary between routine travel and the high warp regime where subspace damage becomes a concern. Warp factor 8, 1,024 times light speed. Alpha Centauri in 36 hours. At this speed, the Federation's fastest ships, Intrepid class, Sovereign class, begin their sprint regimes. Warp 8 was emergency speed for the Galaxy class, sustainable only for hours. Warp factor 9, 1,516 times light speed. Alpha Centauri in just over 1 day. 1 light-year every 5 3/4 hours. The ship is now moving through the galaxy at a pace that makes the local neighborhood, stars within 50 light-years, feel like suburbs. Warp factor 9.2, 1,649 times light speed. The maximum sustainable speed for a Galaxy-class starship. At this velocity, the Enterprise D could theoretically cross the width of the Federation in approximately 5 years. Warp factor 9.6, 1,909 times light speed. 12 hours maximum for a Galaxy class. The hull temperature approaches 1500 Kelvin. The structural integrity field is at 110% of rated capacity. The chief engineer is staring at a display that is mostly red. Warp factor 9.9, 3,053 times light speed. Extreme high warp travel where every decimal place matters. At this speed, a ship moving in a clean, straight line could cross 70,000 light-years in about 23 years, if nothing went wrong, which everything always did. Warp factor 9.975, approximately 5,000 times light speed in many technical references. The Intrepid-class maximum sustainable sprint is often associated with this part of the scale. In pure arithmetic, 70,000 light-years at 5,000 C would be about 14 years. Voyager's famous 75-year journey therefore tells us something important about story world travel. Maximum listed speed is not the same as average practical speed. Routes are indirect, supplies run low, engines need rest, space is full of hazards, politics, detours, hostile territory, and tempting shortcuts that may or may not be traps. Every hour at high warp is an hour closer to home, but the galaxy still resists being crossed. Warp factor 9.99, 7,912 times light speed. Sovereign class emergency speed. The Enterprise E, pursuing the Borg, defending Earth, pushing further into the curve. At this speed, 1 light-year passes every 66 minutes. The ship is held together by structural integrity fields and the sheer will of its crew. Warp factor 9.999, approximately 100,000 times light speed. Theoretical limit of Federation warp technology. No Starfleet vessel has ever achieved this speed in normal space. The energy required approaches infinity. The subspace field begins to interact with the quantum vacuum in ways that are not fully understood. Warp factor 10, infinite velocity, everywhere at once, the point where the warp factor equation becomes undefined. In the Star Trek universe, Warp 10 has been achieved exactly once in recorded Federation history by Tom Paris in the shuttlecraft Cochrane, using a new form of dilithium that allowed the warp field to cross the asymptotic barrier. The result was transformation. Paris became a creature of pure energy, existing at every point in space simultaneously before being returned to human form. The Federation classified transwarp, the regime beyond warp 9.99, as too dangerous for further flight testing. The scale does not truly end at 10. It approaches 10 as an asymptote, a line that is forever getting closer but never touched. And in that approach, in that infinite sequence of nines after the decimal point, is the entire romance of warp drive. The speed is not a number, it is a direction. It is the refusal to accept that any distance is final. When Star Trek was being filmed on the Desilu lot in 1966, no physicist would have said warp drive was possible. Faster than light travel was science fiction, pure and simple. Einstein had spoken. The speed of light was absolute. But Star Trek's version of warp drive, the warp bubble, the contraction of space ahead, the expansion behind, turned out to be not merely science fiction. In 1994, Miguel Alcubierre proved that this configuration was a valid solution to Einstein's field equations of general relativity. The mathematics worked. The universe permits a region of space-time to move faster than light, provided the region itself is carried by the geometry of space-time rather than accelerating through it. Alcubierre's warp bubble contracts space in front and expands it behind. The ship sits in a flat region at the center. Inside the bubble, all the laws of physics hold exactly as they do on Earth. There is no time dilation, no relativistic mass increase, no violation of causality at the local level. The crew experiences nothing unusual. Outside the bubble, from the perspective of distant observers, the ship has moved faster than light, but it did so by surfing on space-time, not by breaking it. This distinction matters because special relativity does not merely say that engines are not powerful enough to outrun light. It says that as an ordinary object with mass accelerates closer and closer to light speed, its energy requirement climbs without limit. A conventional rocket cannot simply push harder until it passes C. It would need infinite energy. Warp drive tries to avoid that trap by moving the geometry around the ship instead of pushing the ship through local space faster than light. The energy requirement was the problem. Alcubierre's original calculation suggested that a warp bubble large enough to transport a starship would require negative energy equivalent to more mass than the entire observable universe. This was not an engineering problem. This was a physics problem. Negative energy, matter with negative mass, which would fall upward in a gravitational field and push instead of pull, has never been observed in macroscopic quantities. But there is a glimmer. The Casimir effect demonstrates that quantum fields can produce regions of effectively negative energy density, very small regions for very brief durations, but real. And beginning in 1999, Chris Vanden Broek showed that by modifying the geometry of the warp bubble, making the interior microscopically thin while keeping the exterior shape, the negative energy requirement could be reduced by dozens of orders of magnitude. By 2011, Harold Sonny White at NASA had reduced the estimate for a usable warp bubble from the mass of the universe to approximately 700 kilograms of negative energy. Still unachievable, still exotic, but no longer cosmic. And in 2021, Eric Lentz showed something remarkable. Subluminal warp drives, bubbles that move slower than light but still faster than any rocket, can exist with positive energy only. No exotic matter required. The Lentz drive and the related Bobrick-Martyr classification of warp drive spacetimes demonstrated that warp technology is not forbidden by known physics. It is merely enormously difficult. There are deeper problems too. A faster-than-light warp bubble may create horizons, regions where information cannot easily travel from the front of the bubble back to the ship. It may sweep up dust, gas, and radiation as it moves, turning ordinary interstellar particles into a dangerous blue-shifted storm. It may raise causality questions, because in relativity, faster-than-light travel in one frame can resemble time travel in another. And even if a bubble could be made, it would have to start, stop, steer, and avoid arriving with catastrophic energy concentrated at its bow. The mathematics opens a door. It does not yet give us a spacecraft. The connection to Star Trek is not accidental. Alcubierre has said in interviews that he was directly inspired by the show. The warp bubble he described in classical general relativity is, in its essential geometry, the same configuration that Zephram Cochrane built in a missile silo in Montana in 2063. The mathematics caught up to the imagination, and the imagination had a head start of 28 years. And so we arrive at the end of our journey through the warp scale, the numbers, the ships, the fictional physics, and the real mathematics that followed. Warp drive, in the Star Trek universe, was never truly about getting somewhere fast. It was about the refusal to accept that distance is final. It was about the belief that the galaxy could be a neighborhood, not a prison. The warp scale from 1 to 10 is a map of that belief. Warp 1, the gate. Warp 5, the threshold of true interstellar civilization. Warp 9, the sprint into the unknown. Warp 9.999, the edge of what is possible, the asymptote, the line forever approached and never crossed. And Warp 10, everywhere at once. Not a speed, but a condition. Not a destination, but a transformation. Whether warp drive ever becomes real, whether the negative energy problem is solved, whether the quantum inequalities permit it, Whether a future Cochrane builds his phoenix in a desert somewhere, the dream itself has already accomplished something. It has given us a vocabulary for the impossible. It has made the speed of light feel less like a wall and more like a door. Tonight, as you drift towards sleep, you might imagine yourself on the bridge of a starship, any starship, watching the stars stretch into lines as the warp field engages. The captain gives an order, the helmsman touches a control, and the galaxy, for a moment, feels like something you could hold in your hand. Warp Factor 1. Good night.